Okay, so to create our feedback buffer, which creates this kind of blur effect, which because of how I have it set up for rendering, it actually pulls the game camera, which is why it's overwriting the scene camera when I turn it on here. But this creates a blur effect by basically taking the previous frame and the current frame and lerping between them by a set value. So what we need to do for those is we need to create another new render feature. So create scripting render feature. And then we'll also need to create a shader for our post-processing. So I named it thermal post-process. And then the feature is also called thermal post-process, just it's a scriptable render feature. Not a great way of naming it, but if I go over to Visual Studio here, so there's two parts to this. This is the render feature. The first thing is we have a material, which is going to be material made from the shader we just created. And we have a pass event. This is the same as our other one where we had a render pass event. This I have after rendering post-processing, so that way it blends after pretty much everything is done except for UI, because we don't want UI to be blended. And then a fade amount. This determines basically the weight of each frame. If it's 0.5, it's lerping halfway between the current color of the current frame and the previous color of the previous frame. We also define a private pass. And then we need two render texture handles, as well as a Boolean that tells us which one to use. So in create, we're going to make a new feedback pass. We're going to define its pass event as the pass event we just set up above. And then we need to allocate two render texture handles. So we say each one is equal to rthandles.alloc. And then in the brackets, the scale bias we leave as 1. Depth buffer bits 0. I use a 16-bit float, an RGBA 16-bit float, and then name it feedback RT0 and feedback RT1. The reason we need two of them is because we have to actually ping pong between them in order to create the effect we want. If we just use one, it overwrites it the same frame that it's trying to blend, and it just doesn't end up doing anything. So we need two of them so that way every frame it's swapping which one of these to use. We also need to have a dispose void here because we're using render texture handles. We need to release them when the feature is disposed. So if you don't have these, you will get a memory leak by having way too many render textures loaded, and it'll never release the texture. So make sure you have this. Then in our add render passes, we just do a check quickly to see if the material isn't set, just return, ignore this completely. And then it determines which handle we're going to use. So it checks the Boolean we defined. And if this is true, we use this one. If it's false, we use that one. So this basically is just a way of swapping between them. And then same thing for the previous. It does the opposite where, see it's 0, 1, or 1, 0. It's just a way to flip-flop back and forth between them each time the pass runs. Then we set up the pass with the material, our fade, and then our two render textures. And then I check if the rendering data.camera data.camera type is equal to camera type.game, then we enqueue the pass. This is to stop it from enqueuing the pass for both the scene camera and the game camera. It was causing me some issues because the scene camera behaves a little bit differently. So it's easier to just have it only work on the game camera, but that's why it was overwriting what we were seeing in the scene view with the game cameras, because this is blitting to the screen. Then we swap the Boolean. So this just runs every frame and it swaps which Boolean we're using. Now in the actual pass here, we have a material, a fade float, our two render texture handles, and then we need to get the shader properties for the feedback render texture and the fade property. So I'm quickly going to swap over to the shader here. In here we have or 4 properties. We have our main texture, which is current frame render texture, frame feedback render texture, previous frame, and a fade, and then a blur size here. So the ones that are important are these two. You need to make sure that whatever these are named are the exact same as what we put in here, because this is how it's finding the property, and it's getting the global ID for this property, so we don't have to look it up by a string. Again, it's like with the other feature, how we were doing the tags by getting the global ID. It's faster to do it this way because string lookups are expensive. So next up in the past data, we have our material, previous frame, current frame, camera color, and fade. In the setup, we're just taking in these values and passing them. And then this, you don't actually need this. This was from when I was testing, but it basically just checks if it's the first frame. It sets both textures to be the same thing. It just stops it from there being no texture, and it can kind of create like a blip of white at the very beginning. So then in the record render graph, which is where we actually enqueue the pass and render graph knows whether or not to execute it, we get the universal resource data. We get the camera color as well by getting the active color texture. And then we import the textures with render graph of our 2 render texture handles. So when we define them up above by allocating them, what we're doing is we're telling this that this is a globally accessible texture in the render pipeline. So the render pipeline needs to create these 2 textures and make them accessible to all shaders or to all render features. So here is where render graph imports those 2 textures. This is where, if it's the first frame, it copies the camera color to both frames and then sets it false. And then in the actual raster pass here, this is the feedback. We set all of the different pass data variables to be our previous, current, and camera color values, as well as our fade and our material. We tell the builder to use the texture for the camera color as well as the previous frame, both with read flags. And then we set a render attachment of the current frame as a write flag. We also, again, disable pass calling. This just stopped some weird issues I was getting. Then in the render function, we feed it the raster graph context and the data. And we set the different values in the material as our different textures. So we're basically telling it this is the amount of fade we want. We're setting the feedback texture to the previous frame, and we're setting the current texture as the camera color. So this is just whatever the camera is outputting. So this is the current frame, this is the previous frame. And then we tell it to draw full screen using the raster graph context command buffer and using the material. Then finally, at the very end, we add a copy pass. This is outside of the raster pass. We add a copy pass to copy the current frame handle to the previous frame handle. So this just makes sure that we're now setting the frame for the next iteration. So in our actual post-process shader, I'll show you what we have here. This is a pretty basic shader. It's a full screen pass, so it's a simple full screen shader. So since it's full screen, we need to get in the vertex ID. We can't use positions in object space because the screen doesn't have a position. And what we do is we get the full screen triangle vertex position of the vertex ID for our position, and for our UV, we get the full screen triangle text coord of the vertex ID. So we need to use these. You can't convert the object to clip space because it doesn't exist in clip space. The screen is separate. Then finally, we have all of our textures and our float, our blur size, and in our fragment shader is where we're actually going to do some of the more complicated stuff. So we need to get the texel size. This is basically a way how it tells the texture how big it is in terms of pixels and divides it, so that way we have a way of knowing how big we need to step through the UV in order to sample each pixel, quote unquote, but this makes it so it's not limited to size and it can be scaled infinitely. So we get the texel size of the frame feedback texture, which will always be the exact same as the main texture. And then we define a color as our previous color. So I'm saying this is just black for now. And then I also have a skipped pixels int that counts up. This is where we get into the blurring. So the blurring is a little bit complicated. You need to have these loop flags active on the shader, because otherwise when it tries to unroll the loop, it won't be able to, because it tries to optimize it. And just with how this loop works and how large it can get, we can't have unrolling happen here. So it needs to execute the loop properly. This does reduce performance, but it was being a pain in my ass trying to get it to work. So this was how I got it to work. But basically we have a nested set of loops here. We have one for X and one for Y, and it goes from negative blur size to positive blur size, and we increase it for each of them. So we determine what the texel shift on X is by getting the uv.x plus the texel size times X. So it's wherever we are here, and this is the offset left or right. And then we check if the texel shift is greater than 1 or less than 0, then add skipped pixels. Since this is for the x-axis, we're actually skipping an entire row here, so we do need to add blur size times 2 plus 1 to our skipped pixels and then continue. If this isn't the case, then it is within the bounds of the texture. Then we continue and we do the same thing for the Y. We determine the texel shift on the Y. And if it's greater than 1 or 0, then again, we skip it. But if neither of them are skipped, then what we do is we add to our previous color a sample texture of the feedback texture here at the texel shift X, texel shift Y. What we're doing here is we're sampling all the pixels in a grid around our main pixel. So we're averaging out the color here. So we add all of them together, and then down here, what we do is we divide it by the size of our, like the total number of pixels minus the skipped pixels. This blur size times 2 plus 1 squared is making a square out of the dimensions of how big we want to sample. We have to subtract the number of skipped pixels in case it goes over. The reason why we skip pixels if it's greater than 1 or less than 0 is because as you're moving around, if you go and there's blurring on the very edge of the screen and you move too far, it'll actually start appearing on the other side of the screen because these textures innately wrap with each other. If it's greater than 1, it'll go, if it's say 1.1, it'll go to 0.1. So we get a wrapping issue if we do that. So by skipping these, we don't have wrapping on the edges of the screen, and it just makes the effect look better. Then finally, we get the current color by sampling the main texture. And then we blend between them using the previous, the current, by our fade value, and we return that blended amount. I know it seems a little bit complicated, but that is how we create this frame feedback effect. And for this, you will have to add these to our render. So we had our render feature in. Now we need to add 2 more. We need to add the thermal post-process as well as our frame feedback, which is a full screen render feature. So your post-processing render feature should appear in here when you add it. The frame feedback, this is actually just a full screen pass. It should appear by default in here as full screen pass render feature, and you'll need to add both of them. For your thermal post-process, turn it on, and then make sure you set the material and the pass event for when you want it to happen. So in this case, I actually have it as before post-processing, but you can have it after. It seems to work fine on before, so we'll leave it that way. And then in our full screen pass, we need to have the same queue. It doesn't have any requirements. I do have fetch color buffer enabled, and then the pass material is the same material we have set up here. Even though in the render feature we tell it to draw full screen with the material, I have no idea why, but it doesn't actually draw it unless you have the full screen pass as well. I don't know why. I'm still trying to figure out. It should be drawing it, but it was not. If anyone here is an expert with RenderGraph or rendering in Unity, please let me know. But I could not get it working for the life of me. So I had to have this full screen pass. But if you enable it, then we have this here. And if I go to our game view, and I press play here, is going to quickly revert me back to this mode, but right now it's actually keeping the old settings that I had, so I have it set fairly high, but as you play with the amount, you can see that it's creating that motion blur. And I can, here, let's see if I can get my scene view up as well. If I change this fade amount to be even lower, you'll see that this motion blur lasts even longer. So the longer that I set, the lower I set the blur, the more intense it is. The higher I set it, it's much more minimal. For the thermal effect, I want something fairly low, but not super low, just to create that kind of trails effect that you get from thermal vision. You can play around with this however much you want. I also actually use this as the transition between visors. So when I'm switching them, what I do is I basically set this fade down to 0.01 for the time it's transitioning. So that way you don't see the instant jump between modes. Instead, it looks like it fades. That's what creates this effect of fading between the views. Now, another thing that you can do is you can change the settings in your shader, your thermal post process. There's the blur size value. Be careful when setting this. This loop it grows exponentially. So the higher the value is, the more it'll kill your GPU to try and run it. So increasing it to 5, the blur is softer, but you can see now the frames are stuttering. That's because my GPU does not like running it that high. So keeping it on 3, I get pretty smooth motion. But play around with it depending on what platform you're using. You might be able to deal with something higher. Just a side note of something to add. If you're going to be turning this feature on and off, which I do depending on when I switch between combat visor or x-ray visor, whatever, something that doesn't use this post-processing effect, make sure that when you call on disable, you dispose the textures. Otherwise, you might notice it a few times throughout the video. I have an error at the bottom that says there are unreleased handles. Make sure that when you call on disable, it disposes them, because the problem is disabling doesn't innately call dispose. So you need to manually call it yourself. So that way it disposes these two render textures. I believe that should fix the issue of why it says there is undisposed textures and should stop there being a memory leak. That's all there is to this. That's how we create the full thermal effect. In the next video, I'm going to show you how to do the X-ray.